Hello everybody, we are continuing our logarithmic functions unit, and today we're going to be talking about equations. This is one of the more complicated lessons, so I want you to pay close attention and please ask as many questions as you can and as you need to when you come to class tomorrow and you practice the equations. Alright, so we're going to start with exponential equations. For exponential equations, you need to be sure that you remember all exponent rules. The power law, the quotient law, the power of a power law, and other things like that. So review, I've posted them on the website. Please review the rules and apply them as you solve the equations. Okay, so our equation number 1 is 3 to the power of x minus 2 equals 5 to the power of x. To solve this equation, we need to use the power law. We are going to take log of 3 and bring the exponent x minus 2 to the front. And we're going to do the same thing here. We take log of the base, bring the exponent to the front. And this is what we get. X minus 2 log 3 equals x log 5. Now what we're doing is we're simply bringing in the log 3 into the bracket. So we're multiplying this log 3 by every term within the bracket. Log 3 times x log 3 times negative 2. And we're getting x log 3 minus 2 log 3 equals x log 5. Let's group the like terms. We're going to call them that. So we're going to group the logs with x's and equate it to log 3. X log 3 minus x log 5 equals 2 log 3. Why were we doing this? Because we can now factor out the x and solve for it. So from here we have x, and here we have x as well. Factor it out, and you're going to be left with log 3 minus log 5 equals 2 log 3. And after you've done that, you can simply have your isolate for x and have 2 log 3 over log 3 minus log 5. All you have to do after this is calculate. So evaluate this, that, and that. Turn these into actual values. If you leave it in this form on the test, I'm going to accept it as long as you got the right logs of the right bases, the right numbers. In the previous example, we were looking at the simpler exponential equation. Now we're going to bring in quadratics. If you look at this equation right here, you'll see that there is something similar. See, 3 here, and 27 can also have base 3, right? When we have 3 to the power of 2x, we need to think how we got that 2x. We brought 3 to the power of x to the power of 2, because we only multiply exponents when we apply the power of a power rule. So power of a power, right? 3 to the power of x to the power of 2. Subtract 6 of 3 times 3 to the power of x minus 27 equals 0. Now look, 3x squared minus 6 3x minus 27 equals 0. Can you see the pattern? Yeah, the pattern is that this reminds us of a quadratic equation. Ax squared plus bx plus c equals 0. So what we're going to do is we're going to substitute 3 to the power of x with u, or x, or any other letter that you like. So now we have u squared minus 6u minus 27 equals 0. From here, it's easy because it looks like a simple quadratic equation now, and we can factor the equation and find our roots. So here we have u minus 9 times u plus 3 equals 0. U equals 9, but remember u was representing 3 to the power of x, so now I'm substituting it back in, and I'm gonna get 3 to the power of x equals 9. Which exponent do I need to raise 3 to get 9? Exponent 2. Same thing here, except 3 to the power of x equals negative 3. And we all remember that we can't take log of a negative number. Nothing to any power will give me negative 3. So this solution is undefined. Our only root for this equation is x equals 2. Power of x plus 12 times 2 to the negative x equals 7. Well, it's tricky, but you have to try and figure out what you need to do with those exponents and bases to get to a simpler quadratic equation. So here we have 2 to the power of x. We can't really do anything much with it, but in this case we can simplify it and turn 2 to the power of negative x into 1 over 2 to the power of x. We have a denominator now, which is 2 to the power of x. We're going to multiply our whole equation by that denominator to get rid of it. So if I multiply 2 to the power of x by 2 to the power of x, I'm going to get 2 to the power of x squared. If I multiply 1 over 2 to the power of x by 2 to the power of x, I'm going to have them cancel out and I'll be left with 12. And here I have subtract 7 times 2 to the power of x equals 0. And this is what I'm ending up with. 2 to the power of x squared minus 7 times 2 to the power of x plus 12 equals 0. Again, this reminds me of quadratics. I hope it reminds you of quadratics too. Now we're going to substitute u with 2 to the power of x and solve quadratic equation. U squared minus 7u plus 12 equals 0. Factor it, u minus 3, u minus 4. Now u was 2 to the power of x, so I'm going to substitute it back. So 2 to the power of x equals 3. X from here equals log 3 over log 2. 2 to the power of x equals 4. X equals 2. Now you try. Look at the following equation. Pause the video and try to solve it. Okay, let's take it up and look at the solution. So 9 to the power of x can be represented as 3 to the power of x squared plus 3 squared times 3 to the power of x, because when I multiply the bases with two exponents, I'm adding the exponents. Subtract 10 equals 0. I have a quadratic equation again. 3 to the power of x squared plus 9 times 3 to the power of x minus 10 equals 0. I can substitute my 3 to the power of x with u and simply solve a quadratic equation again. U squared plus 9u minus 10 equals 0. My two factors are 10 and negative 1. And so my zeros are 3 to the power of x equals negative 10 is undefined because it can be negative. 3 to the power of x equals 1. X equals 0 because 3 to the power of 0 will give me 1. I hope you got the right answer when you solved it on your own. If not, please ask the questions tomorrow. So, except exponential equations, we also have logarithmic equations. Let's look at the simpler one. Log 6 of x minus 5 equals 2. for log equations, you have to remember the setup of the log expression. 6 is the base, x minus 5 is the answer, and 2 is the exponent. I raised my 6 to the exponent 2 to get the answer x minus 5. And this is what I do to solve the equation. 6 to the power of 2 equals x minus 5. From here it's easy, you just solve for x. 36 equals x minus 5 and x equals 41. For log equations, please remember to state the restrictions every time you solve it. It doesn't say here, but log of 0 will be undefined, or log of negative number will be undefined. So x in this case cannot be what? Can you answer this tomorrow for me? Let's look at example number 2. Here you notice that we have a product law. The sum of two logs can be a single log of a product of two answers. And again, we're going to apply the properties of logs where 6 is the base, x plus 3 times x minus 2 is the answer, and 1 is the exponent. So first I'm applying the product rule, and I'm going to have log 6 of x plus 3 times x minus 2 equals 1. 6 to the power of 1 equals this. This is my answer. 6 is my base. 1 is my exponent. 6 to the power of 1 is 6. Here I am expanding and getting a quadratic equation. I'm bringing 6 over, and this is what I get. X squared plus x minus 12 equals 0. I factor it, and my two factors are x equals negative 4, x equals 3. Again, I did not state the restrictions on purpose here. I want you to think about it. Which x satisfies the equation and which x does not? We are going to talk about it in class. Please think about it. In our last example, we're going to be dealing with a quotient rule. If you look here, I can move log 5x minus 1 to the other side, and I'm going to have a quotient rule. So log 5x minus log 5x minus 1 equals 1 can become log 5x divided by x minus 1 equals 1. Again, if I apply the characteristics of log to this, I'll get base to the power of 1 equals the answer. So 5 to the power of 1 equals x over x minus 1. What can my x not be? Think about it. What can I not divide by? 0, of course. And what x will make my denominator 0? Here it is. Okay, now we're moving on and solving it like a rational equation. Remember? Rational functions. Yeah, we're doing the same thing here again. Okay, so we're bringing it to the common denominator. As soon as we have the same denominator, we can completely get rid of it and just work with the numerator. So we'll have x equals 5x minus 5. From here, x equals 5 over 4, or 1 and 1/4.